Okay, so we will start our first lecture with the chirality and achirality of the molecules, which is the most basic concept in organic chemistry. So let's begin it with the basic definition. So an object is chiral if its mirror image is different from the original object, and here they give us an example about the hand. If we see the reflection of a right hand in the mirror, then we will consider the reflection, and the reflection would be like the left hand. And if we pick the reflection and try to impose on the on that object which is producing its reflection, then we will see that they are non superimposable on each other. So this is the common definition of the chirality. Further we will see how we will distinguish between the chiral carbon centers and achiral centers, but this is about the broad idea of the chirality. And now the achiral mirror images that can be superimposed are achiral, means they would be not chiral. So here they give us an example of a chair. If we will see in the mirror reflection, then and try to pick this molecule, we will pick this object and try to impose on the original entity or any object, then they would be superimposed on each other. So this is a broad definition of the achirality. So stereochemistry is basically a difficult topic for the students, and we have to realize it with the original molecules, but we will try to understand from the 2D molecules as well. So enantiomers. So enantiomers are basically the molecules which are non-superimposable on each other. So let's understand from this example. Like this is the carbon. This is the carbon, and it has 4 different groups, like 1, 2, 3 and 4. So 4 different groups are attached to that carbon. So what would we call this carbon? So we will call it a chiral carbon. Okay, and when we will see in the mirror, then it will produce its reflection. Okay, it will produce its reflection. So if the bromine is on this side and hydrogen in this side, then in the reflection it will be the reverse of that, the original one. So, and if we pick this molecule and try to impose on the original one, then we will see that it would not impose on each other. It would not impose on each other, and they would be different, but although it has the same groups attached to it, like this bromine, hydrogen, methyl and ethyl, bromine, hydrogen, ethyl and methyl and ethyl, but these are non-superimposable on each other, though they have the same molecular formula, same structure formula, but they are non-superimposable. So we will call them the enantiomers. And the next is chiral carbon atom. So about the basic definition, also we will call the chiral carbon an asymmetric carbon atom. A carbon atom that is bonded to 4 different groups is chiral. Its mirror image will be different compounds. So if its mirror image is different compound, then we will call it the enantiomer. So now the stereocenters, an asymmetric carbon, what we will call the other name of the asymmetric carbon, that is chiral carbon, is the most common example of the chirality center. So chiral centers belong to an even broader group called stereocenters. Okay, we will call also them stereocenter. So a stereocenter is any atom at which the interchange of 2 groups gives a stereoisomer. For example, okay, we will understand it the example later given. Asymmetric carbon and a double bonded carbon in cis-trans isomers are the most common of stereoisomers. So we will understand in the example. So for example, we have a molecule, the 4 different groups are attached to it, like methyl, ethyl, hydrogen and bromine. So this is an asymmetric carbon, or we will also call it a chiral carbon. And there is another molecule, nitrogen, and 4 different groups are attached to it. See, this is propyl, ethyl, this is also like isopropyl and methyl. So these 2 carbons are chiral carbons or chiral centers or asymmetric carbon. And see in this molecule, the carbon, this is a first group attached to it, a second one and a third one. Okay, so